Electrical principles form the foundation of our understanding of how electricity works and how it can be harnessed. Here's a discussion of the basic concepts. 1. Electric charge. At the most fundamental level, electricity is about electric charge. There are two types of charge: positive, plus, charge, associated with protons within an atom's nucleus; negative, charge, associated with electrons orbiting the nucleus. Key principles. Like charges repel, two positive charges will push each other away, as will two negative charges. Unlike charges attract, a positive charge and a negative charge will pull towards each other. Quantization of charge. Electric charge exists in discrete units, the smallest being the charge of a single electron or proton, approximately 1.602 times 10 to the power of minus 19 coulombs. Conservation of charge. Charge cannot be created or destroyed, only transferred from one object to another. 2. Current I. Electric current is the flow of electric charge. Specifically, it's defined as the rate at which charge passes a given point in a circuit. Symbol, I. Unit, ampere A, which is equivalent to 1 coulomb per second, see sextil. Direction. Conventionally, current is said to flow from the positive terminal to the negative terminal. Conventional current. However, in most conductors, it's the negatively charged electrons that actually move from the negative to the positive terminal. 3. Voltage, V. Voltage, also known as electric potential difference or electromotive force, EMF, is the push or pressure that drives electric current. It's the work done per unit charge to move a charge between 2 points in an electric field. Symbol, V or E. Unit, volt V, which is equivalent to 1 joule per coulomb, JC. Analogy. Think of voltage like water pressure in a pipe. Higher pressure, voltage, will cause more water, current, to flow, given the same pipe size, resistance. 4. Resistance R. Resistance is the opposition to the flow of electric current. Materials that have high resistance are called insulators, while materials with low resistance are called conductors. Symbol, R. Unit, ohm, omega. Factors affecting resistance. Material. Different materials have inherent resistivity. Length. Longer wires have more resistance. Cross-sectional area. Thicker wires have less resistance. Temperature. For most conductors, resistance increases with temperature. 5. Ohm's law. Ohm's law is a fundamental relationship between voltage, current, and resistance in a DC direct current circuit. Formula: V equals I times R, where V is voltage in volts, VI is current in amperes, AR is resistance in ohms, omega, rearrangements, I equals V divided by R equals V divided by I. Significance. Ohm's law allows us to calculate any one of the three quantities if the other two are known. It's a cornerstone of circuit analysis. 6. Power P. Electric power is the rate at which electrical energy is converted into other forms of energy, like heat, light, or mechanical energy. Symbol, P. Unit, watt, W, which is equivalent to 1 joule per second J seconds. Formulas, derived from Ohm's law. P equals V times I, P equals Ido, the power of 2 times R. By substituting V equals IR, P equals VTO, the power of 2/R. By substituting I equals VR. 7. Circuits. An electric circuit is a closed loop through which electric current can flow. Basic components include power source, provides the voltage, e.g., battery, generator. Conductors, wires that allow current to flow. Load, a device that consumes electrical energy and converts it into another form, e.g., light bulb, motor, resistor. Switch, controls the flow of current, opens or closes the circuit. Types of circuits. Series circuit. Components are connected end to end, forming a single path for current. Current is the same through all components. Total voltage is the sum of individual voltages across components. Total resistance is the sum of individual resistances. Parallel circuit. Components are connected across the same 2 points, providing multiple paths for current. Voltage is the same across all components. Total current is the sum of currents through individual branches. Total resistance is less than the smallest individual resistance. Reciprocal sum formula for resistors. 8. AC versus DC. Direct current, DC. Current flows in only one direction. Examples: batteries, solar cells. Alternating current, AC. Current periodically reverses direction. Examples: household electricity, power from generators. AC is more efficient for long-distance power transmission. These basic principles form the foundation for understanding more complex electrical phenomena and are essential for anyone working with or studying electricity and electronics.